All right, so let's get started on the first category, which is find trig ratio given another, this time in 4 quadrants. So it's very similar to what we did last time, but let me, first of all, remind you what happens in those 4 quadrants. So let me just draw a unit circle first. Let me zoom in here. Okay, so we got quadrant 1 on this side, which is where we focused all of our triangles last time. Here's quadrant 2, 3, and 4. Okay, so in case you don't remember how the quadrants are labeled, you should draw this picture in now. So in quadrant 1, like any point that's in this quadrant will have a positive x value because you're going to the right of the origin, so positive x value, and you are also above the origin, so you have a positive y value as well. And then moving on to quadrant 2, you have a negative x value because you're now to the left, but you still have a positive y value. In quadrant 3, you are still to the left, so a negative x value, but now you're also downwards, so a negative y value. And in quadrant 4, your x value is positive because you're to the right, and your y value is negative because you're to the bottom of the origin. Okay, so this will all come in handy later when we are doing our triangle drawings. Okay, so just keep this in mind. Remember the x's and the y's, if they're positive or negative in each of these 4 quadrants. So I'm gonna pause the recording here and then see, just to give you guys more time to copy this down in case you need it. All right, so we waited and I think you guys are done copying this. So let's get on to the actual problem that is being given to us. So that over here it says given sine of theta is 5/13 and angle theta terminates in quadrant 2, then what is the value of cosine? So I'm going to draw another picture, a fresh unit circle over here for us. And I'm just going to pick a point, any point in quadrant 2. So this is quadrant 2. And so to draw this triangle in quadrant 2, you want to connect your point to the origin, and then from the point, drop straight down to the x-axis, forming your right angle. Sorry, that took a while to say for some reason. Okay, and technically the angle theta is this one, but we're still going to treat this as our reference angle for now. Okay, so angle theta that's being talked about is technically this angle on the right side that I've marked as theta. And then when we are doing our our triangle calculations, for the sake of simplicity, we're just going to focus in on the inner corner angle that I've marked with 2 arc marks. Okay, so according to SOHCAHTOA, which we talked about yesterday, sine would be referred to in this part, the SOH. So sine is opposite over hypotenuse. Hopefully that sounds familiar. And so sine being opposite over hypotenuse, that's the 5/13. And so let's label it in our unit circle. So from the reference angle, we have our opposite side being 5, so I label it over here, and the hypotenuse being 13, so I'm going to label that over here. Okay, any questions up until this point? All right, so remember that you can always interrupt me if you do have a question, just let me know. So finally, they're asking, what is the value of cosine theta? So I'm just going to do this in a different color, just so that we get, it looks a little more neat. So according to SOHCAHTOA, cosine is going to be the adjacent over the hypotenuse. Now you'll notice we don't have the adjacent side yet, so we need to use the Pythagorean theorem to solve for our unknown side. I'm just going to call this unknown side A, the other leg can be B, and C is always the hypotenuse, okay? I don't know why these lines are happening here. Okay, there we go. Okay, so we have our a, b, and c. We're going to use the Pythagorean theorem to solve for a because we don't know what a is yet, and we need a to do our cosine. So let's use the Pythagorean theorem. A squared plus b squared equals c squared. So we don't know what a is, but then we do know that b is 5. So plus 5 squared equals 13 squared. And then solving for a, we get a squared plus 25 equals 169. And then you subtract 25 on both sides. You get a squared is equal to 144. Then to get the a by itself, we're going to square root. Square root, we get a is equal to 12. Any questions on this part? All right, I'm labeling it 12 on our little triangle within our unit circle. It's not a unit circle. Within our circle, I'm labeling this 12. Okay, so then we're going to solve for cosine of theta. So the adjacent would be the 12 over the hypotenuse would be the 13. So our cosine of theta is 12 over 13. Oh wait, there's one more thing I forgot. Remember in quadrant 2, the x value has to be negative. So the x value would be the horizontal portion over here. This red line that I drew in our triangle. That part, since we're going to the left of the origin, this has to be a negative x value. So instead of a positive 12, it has to be a negative 12. Are there any questions on that? So like literally this black point, the coordinates of it, given that this is the origin, it goes 12 to the left, so it's negative 12, comma, and it goes up 5. So this is the coordinate of that black dot. So the fact that we went 12 to the left means it's got a negative x value. So in our answer, I need to make sure it's a negative 12. So our answer is actually negative 12 over 13. Any questions on that entire problem? So whichever number we solve for, it will always be negative? No. So it depends on which quadrant you're in. So according to, I can zoom in like that. According to this little image that we drew of the circle on the right side, like this image of the circle, there we go, I can point. If you're in quadrant 1, everything's going to be positive. If you're in quadrant 2, so this is quadrant 2. If you're in quadrant 2, your x value is going to be negative, which means like this direction, whatever's on the bottom of your triangle, that's going to be negative. But the upwards direction will still be positive, because if you pick any points on quadrant 2, you go to the left, that's got to be negative, but you still go up, so the up is positive, okay? And then we'll do an example for quadrant 3 and 4 later. I just don't want to draw over this picture so much until it turns into a mess. So we'll definitely do examples in quadrants 3 and 4. Any questions on this one before we do that? Type yes in the chat if you have a question. In the next 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so let me go enter this in. What was the answer? Negative 12 over 13. Negative 12 over 13. Okay, gonna look for quadrant 3. I'm just gonna look for quadrant 3 or 4. Just gonna keep giving up until they do that for me. There we go, here's a quadrant 4. So let's do this one. Okay, so let me just quickly draw that circle centered at the origin over here again for you. So 1, 2, 3, 4. And remember that in this, we have positive, positive for quadrant 1. We have negative, positive for quadrant 2. We got negative, negative for quadrant 3. And in quadrant 4, we got positive, negative. And in case you didn't catch it the first time, this is like the x value, this is the y value. So I'm just saying, like, in quadrant 1, the x and y are both positive. In quadrant 2, the x is negative, the y is positive. In quadrant 3, both are negative, and in quadrant 4, x is positive, y is negative, based on their relative position to the center. So I'm repeating that because I know some people came in later. Okay, so here's the circle, and we're going to use this information when we do this problem. So they say that sine is negative 60 over 61, and the angle theta terminates in quadrant 4. We want to find the value of tangent. So let me draw a circle. Remember, for these problems, you should always be drawing a circle. As ugly as your circle may be, like mine's ugly, it's fine. Just pick a point in quadrant 4 where you can draw a triangle. So on this triangle, here's what you do. Here's how you make your triangle. You have the points in quadrant 4, you connect it to the center. And then, since we're on the bottom, you're gonna not drop it, but rise a line straight up until you hit the x-axis. So this is what your triangle should look like. And where is the theta? So theta is actually going to be from the 0 degrees all the way around to reach your terminal side, that line. So this entire giant thing, this angle is theta. However, for the purposes of our triangle, we're going to focus in on this guy as our reference angle, okay? So we're just gonna use that thing as our reference angle. Okay, so let's remind ourselves, what is sine? According to SOHCAHTOA, which I don't have as much space this time to write that in, so I'll just write it here. According to SOHCAHTOA, sine will be opposite over hypotenuse. So we have negative 60 over 61. And let's put that into our triangle. So the hypotenuse and the opposite, when you divide them, you get a negative number. But I'm telling you now that the hypotenuse is always positive, because the hypotenuse is literally just the radius. It's the distance from the center to your point. So the hypotenuse, the 61, is just going to be positive 61. So the negative gets taken by the opposite. So the opposite's over here. And you can see that makes sense because, let me mark it in the blue color. This distance that we went down from the x-axis, because you're going down, it has to be a negative number. So it's like a negative y value because you went downwards. So negative y value, that's why your opposite is a negative 60. It's a 60, not a 61, my bad. Negative 60. Okay, so that one gets to be negative because it's the y value and you went down. Okay? Any questions up until this point? I'm gonna pause the recording, so I'll just give you guys a second to process and see if you have any questions. All right, so let's solve for our unknown side. So let me show you in red. No, I don't want to use red yet. Let me just show you our unknown side's this one. So I'm gonna call it A. And then we have our B over here, the other leg, and C is always the hypotenuse. And we're gonna plug this into the Pythagorean formula, Pythagorean theorem. Okay, a squared plus b squared equals c squared. That's our formula. Let's plug it in. We don't know what a squared is, but b is negative 60 equals c squared. And so we're gonna do this on, we're gonna simplify this. So negative 60 squared, that's a 0, be 600, equals, I don't know what 61 squared is, so I'm gonna use a calculator. It would be 3721, and then subtract you get a squared is equal to 121, and square root, you get a is equal to 11. Okay, so now that we got our a value from the Pythagorean theorem, I'm going to put it on our triangle. Now you have to think to yourself, is this 11 going to be positive or is it going to be negative? So you can either refer to the circle that we drew on the right side, and remember that in quadrant 4, your x value, your left-right direction, is going to be positive. Let me point. It's going to be positive in the quadrant 4 because you're moving to the right. And you can also see that in our picture over here, it's from the origin, you go to the right 11. So since you're going to the right, this is your positive x value. So it's a positive 11, okay? All right, next we're going to do tangent of theta. So we have a TOA in SOHCAHTOA to remind us that tangent is opposite over adjacent. And so let's do that. We have the opposite side. Let me just do this in a different color now. We have the opposite side over the adjacent. And so that would be our final answer, negative 60 over 11. Well, I mean, you can ask yourself, can you simplify this? And in this case, you cannot because 11 is a prime number. But if you could simplify it, then you would have to. So our answer is negative 60 over 11. Any questions? All right, so it doesn't sound like you guys have any questions, so I'm going to enter this in, and then we're going to move to another example. Okay, let's look for quadrant 3 as I lose all my points giving up. Give up. Oh, yay! I didn't lose all my points. I only lost most of them. Okay, so let's do our circle drawing. And we have, given that cosine theta is equal to negative 65 over 97, and the angle theta terminates in quadrant 3, then what is the value of sine? So let's take a look. Over here is quadrant 3. And so how would you draw a triangle in quadrant 3? You connect it to the center. Sorry, I don't know why it's so squiggly, whatever. Connect it to the center and then drop the line straight upwards so that you make your right angle there. So I wanted to make sure I show you guys an example from 2, 3, and 4 so that you guys know how to draw your triangles in each of those quadrants, okay? So this is how you draw your triangle here. Angle theta is technically this one, but for our purposes, we're going to be using that as the reference angle, okay? So we have, according to SOHCAHTOA, that cosine is adjacent over hypotenuse. So our adjacent over hypotenuse is negative 65 over 97. Okay, so remember what I said about the hypotenuse? The hypotenuse is just the distance from the center to your point, which means that it's always going to be positive. So the hypotenuse always stays positive. Then the adjacent side is what takes the negative value, so it's a negative 65. And that makes sense because to get to this giant blob of a point, which has the coordinate of negative 65, comma, something, we don't know that something yet, but to get to that point, you have to go left 65 units. So that means it's got a negative 65 x value. So just to remind you that this point has a coordinate of negative 65, comma, something. That something we're going to solve for using the Pythagorean theorem. So this is our A, this is our B, and hypotenuse is our C. So let's plug it in. We got negative 65 squared plus B squared equals 97 squared. I'm gonna use my calculator because in my head I just don't know what that is. 65 times 65 is 4225 plus B squared equals 97 times 97. Okay, there we go. Oh, just to remind you guys, when you square a negative number, like I did over here, the negative times itself results in a positive number, okay? So this is not a negative 4,225. It is a positive 4,225. Okay, so then we're going to subtract. We get b squared is equal to, I shouldn't have put my calculator away. And then we square root. And we get b is equal to 72. Cool. Any questions up until solving for that b value? Okay, I'm going to put 72 over here. And then notice that this 72 is I'll do it in blue, in the downwards direction. So from the origin, if you have to go downwards, this actually becomes a negative 72. So really our b value is a negative 72, which means our y value of this giant black dot is a negative 72. Okay, so technically our giant black dot has the coordinates of negative 65, negative 72. And so we have our triangle labeled. Are there any questions? Okay, so let's solve for sine of theta now. According to SOHCAHTOA, sine is opposite over hypotenuse. So let's do our opposite over the hypotenuse. And there we go. That's our answer. Negative 72 over 97. Then you just kind of ask yourself, can this be simplified? I don't think so. So let's just leave it like that. Negative 72 over 97. Negative 72 over 97. Cool. So now I have 1.75 points. Okay, so that's it for this section. I'm going to stop this recording.